All right, so next we're going to be looking at some more identities, and more specifically, we're going to be looking at the sum and difference identities that are out there for sine, cosine, and tangent. What these identities do is they allow us to find exact values of angle measures that are not necessarily on our unit circles. For example, we'll be looking at finding the exact value of, we'll be taking a look at the sine of 7 pi over 12, which is not located on our unit circle. We'll be looking at trying to find the cosine of 15 degrees, the tangent of, we could do, we've got a variety of different angles that we can use, really just by taking 30, 60, 90, 45 degrees and adding those to each other and subtracting them from one another to end up getting some new exact answers. So the three formulas that we're working with is, first of all, the cosine of u plus or minus v. So when you're taking the sum or difference and the cosine of the sum or difference of two angles, here's our formula that's going to be used. You'll notice that we have the plus or minus that's getting used here. And this just says, okay, if we're going to take 30 degrees plus 45 degrees, then when I get over here, just be careful of the sign change, because if we're adding, I'm actually going to be using the subtraction symbol between these two. If I was taking 45 degrees and subtracting 30 degrees, then I would use the addition. But we're going to take the cosine of the first angle times the cosine of the second angle, subtract or add, take the sine of the first angle times the sine of the second angle. For sine, it looks very similar. Sine of two angles being added or subtracted. This time, instead of cosine and cosine, now you're taking the sine of the first value, angle times the cosine of the first angle, plus or minus the cosine of the first value times the sine of the second value. And then the last one here is working with our tangent and the sum or difference. So we're going to take the tangent of the first measure plus or minus the tangent of the second, divide all of that by 1 minus or plus the tangent of the first divided by the tangent of the second. So what I'm going to do is go through a couple examples just to help you see what we are doing here, and then we'll be using this in class in a couple different ways. So the first one that I'm going to do here is the sine of 7 pi over 12. So as you know, that is not on our unit circle, and probably the hardest part of this is the fact that we're not real great with fractions. So what we need to try and think of here is, how can I get really essentially 7/12ths, since we've been working with pi over 3, so 1/3, pi over 4, which is 1/4. We've been talking about pi over 6 of 1/6, then we've been working with halves and so on. So we're trying to figure out how can we end up with 7/12ths from these values. Well, 7/12ths, we could get that by taking and adding pi over 3 plus pi over 4. Because in order to add together, we have to have common denominators. So the common denominator between 3 and 4 would be 12. And so now we can end up taking, if I did that here, I get 4 pi over 12 plus 3 pi over 12, which ends up giving us 7 pi over 12. So with my formula that I'm using then, since I'm taking the sine of a sum, I'm going to take the sine of the first value here of pi over 3. I'm going to then multiply it by the cosine of the second value, which is pi over 4. And because I'm adding these two right here, I'm going to add the next part here, where we're going to take the cosine of the first term, which is pi over 3, and multiply it by the sine of the second term, which is pi over 4. So we went from working with this 7 pi over 12, which is not on our unit circle, to now I have 4 values that are on our unit circle, and we can find those values fairly easy. The sine of pi over 3 gives us the square root of 3 over 2. The cosine of pi over 4 is going to give me the square root of 2 over 2, plus cosine of pi over 3 is 1/2, and the sine of pi over 4 is the square root of 2 over 2. So when I multiply fractions, I multiply straight across, giving me the square root of 6 over 4, plus the square root of 2 over 4. Because I have common denominators, I can go ahead and add my numerators together, but I have to keep them separate since they're not similar radicands, and there we have the square root of 6 plus the square root of 2 all over 4. The second example that I'm going to go through and do here is an example using tangent. And I'm going to use degrees this time. So we're going to do the tangent of 15 degrees. And so I've got to think about how can I get the tangent of 15 degrees working with 30, 45, and 90. So when I look at that, I say, okay, we could go ahead and take 45 degrees, sorry, and subtract 30 degrees from it, and that would give me 15 degrees. So using my formula that I have now, I'm going to be taking the tangent of the first value. All right, so we're going to go ahead and take the tangent of the first value, which is 45 degrees, and then we're going to be subtracting the tangent of the second value, which is going to give us 30. And then we're going to divide all of this by 1. And this time, since I'm subtracting, I'm using the difference, because it's minus plus on the formula that we have. Since I'm subtracting here, I'm actually going to be adding, so 1 plus the tangent of the first value of 45 degrees times the tangent of the second value, which is 30. So I'm going to fill in the information that I know. The tangent of 45 degrees is 1. And then I'm going to have minus the tangent of 30 degrees, which is the square root of 3 over 3. And this is all going to be over 1 plus the tangent of 45 degrees, which is 1, and the tangent of 30 degrees, which is the square root of 3 over 3. So from here, I'm going to give myself a little bit more room. All right, so from here we're going to simplify, and this usually tends to be the hardest part for people because of working with the fractions. 1 minus the square root of 3 over 3, we have to have a common denominator, so I'm going to think of that as 3 over 3. This now gives me 3 minus the square root of 3 all over 3 divided by 1 times the square root of 3 over 3 is square root of 3 over 3. And now I'm taking 1 and adding that, so we have to have common denominators again, so 3 over 3. And then when I add, we're going to get 3 plus the square root of 3 all over 3. So I'm just using my basic properties for adding and subtracting, multiplying fractions. So at this point right now, we have two fractions, which to simplify those, remember we always want to multiply by the reciprocal. 3 minus the square root of 3 over 3 times 3 over 3 plus the square root of 3. And because I'm multiplying at this point, I can cancel out the 3 here and I can cancel out the 3 here because those are being multiplied together, so they are becoming factors of each other. What will not cancel out here are the 3's or the square root of 3's. Those are going to stay as is, giving me 3 minus the square root of 3 over 3 plus the square root of 3. Now we would be finished except for, as mathematicians don't like having square roots in their denominator, we need to multiply by the conjugate here of 3 minus the square root of 3. So you'll remember that we did that more towards the beginning of the year. And by doing that, now I'm going to have to FOIL out my numerator and denominator. 3 times 3 is 9. I'm going to end up with negative 6 square roots of 3 plus 3. Negative square root of 3 times negative square root of 3 is positive 3. And then down below, my middle terms are going to cancel, but I'm going to be left with 9 minus 3. And so then as I'm finishing, sorry, I just need a little bit more room. Squeeze that all together. So then here I end up with, on the top, we've got 12 minus 6 square roots of 3. 9 minus 3 is 6. And then 12 divided by 6 is 2. 6 over 6 is 1. So I get 2 minus the square root of 3. So if we're going to try and find the exact measure, you're going to see that we have to work through this more so just basic algebra that we're working through to be able to solve that. The last examples that I'm going to go through are how do we look at a little bit easier of an example here, but simplifying. So if you were given a problem like this, we could end up simplifying this down to one value of sine or cosine. So I've got the sine of 42 degrees times the cosine of 17, cosine of 42 times the sine of 17. Well, what this is doing here is this is going to be based off of the minus sign that we have here, is this is it's the sign of the difference of two angle measures when I look at those two values. So here, if I wanted to, I could rewrite this as a single value of sine and take 42 and subtract 17 degrees, which would end up giving us the sine of 25 degrees. So this long expression here is the exact same thing as the sine of 25 degrees. I could do the same thing with number 2 here, taking the cosine of a radian times the cosine of a radian, sine of a radian, and, sorry, this is supposed to be the sine. So then you've got the sine of another radian. With that being said, what's happening here is now we have the cosine of, and then with the plus sign right here, we'd be looking at the cosine of the difference. So I'm going to be taking the cosine of pi over 5 minus pi over 2, which is, working through this, we have to have common denominators, which would be 10. So if we think about this as 2 pi over 10 minus 5 pi over 10, and then we would end up with the cosine of negative 3 pi over 10. So you've seen me go through two separate different examples, one finding exact values using the formulas, and also one trying to simplify the expressions that are given. We're also going to be looking at how do we use these into our proofs and our simplifying of identities when we get into class tomorrow. So if you have any questions on anything, make sure you let me know. Otherwise, try and see if maybe you can go through the two examples here on your own. Perhaps you want to try and find out what is the cosine of 7 pi over 12. Do something like that to see if you see how comfortable you feel.